Hey, Katie.
Hi.
So anyway, we're here in G Block. We missed you, but we're gonna hopefully let you listen in on class. We'll see how it goes. All right. Okay. Ready, guys? Okay. Now I feel like she's watching us. So okay. All right. So as I talked about earlier, the the lesson today is the exact same thing we did last time, only now we're going to add something to the final step at the end. Okay, so what we're going to do is we learned increasing and decreasing last time. Now we're going to use the fact that that we know a function is increasing or decreasing to find where it might have a relative min or a relative max. So who can tell me what a relative min or max might mean? Well, it's the highest that it goes or lowest that it goes relative to the points around it. Okay, yeah, very good. So later on, we're going to learn about absolute maximums and minimums, which is the highest it goes ever or the lowest it goes ever. But today, we're going to talk about relative mins and maxes. So like this point right here would be a relative max because in relation to just like this interval, it's the highest point, right? This point right here would be a relative min because relative to everything around it, it's the lowest point. Does that make sense? So really every kind of turning point becomes or can become a relative min or max. This right here, which is called a cusp, would be a relative max, right? And this one would be a relative min. Okay? Now, the way we use, so this again is just kind of textbook speak for the definition of a relative min or max. And again, because your next math class probably not explain things like high schools do, so I want to get you all used to. So this is just saying for a function f defined over any open interval a, b containing c. So that just means if we have some graph that we're looking at, and we're looking at it in some interval, we can name an interval anywhere, and we'll call the endpoints a or b, and c represents any possible point in there. Okay, so that's just what this means. It means any open interval a to b that contains some point c. Then, this is just saying if f of x, so if the y value for all the x's is less than the y values for the c point, then c is a max, right? So it's just saying if, like, well, this is a min actually, but we're saying if c is the highest point from all the other x's in that interval, then c is a max, right? And then the other statement says if f of x, meaning the y values for the x for all the x's is greater than f of c, right, or the y value of c, then c is a relative min. Okay, so that's just kind of the technical jargon that that they use to define max and mins. So what we're going to do, and actually I can kind of give this lesson, a summary of this lesson really quick. So in our homework, like right over there, we have the fact that we found a critical point at 0. I'm just copying this thing. All right, homework answered over there. So we talked about how 27, our homework, had a critical point at 0. It was decreasing, coming up to 0, right, and increasing. So if we know that that's happening, that it's increasing and then going, and then that it's decreasing and increasing, so then what is happening at 0? Is it a max or a min? It's a min, right? How do we know it's a min? It's going down and up, right? So if we had done one from our previous book where we found that it was going up and then down, so this is a min, then if this were an answer to our homework, it was coming up, going up to -1, and then going down, what is happening at -1? It's a max, right? See, so that's the lesson. So we're going to do a little bit more. We're going to do some examples. But what we're going to do then is we're going to identify what the critical numbers are, like whether they're mins or maxes. And then we also want to find out, okay, if this is a min, then what is the y value at that point? How low does the function go? And so we have to plug that into the original equation. And that's actually what messes people up more than anything, is that in all of your homework, you kept plugging back into the derivative. Well, now, to do the final answer, you have to plug back into the original function. And that ends up, more people miss points on that kind of thing. Just remember that. Okay? Okay, so our first derivative test, okay, just want to make sure we're still going there. Because now we're going to say, okay, it's a min. So like when we have a function like this, like we're going like this. So we identify that, yeah, there's a min right here, okay? But to answer, we want to say, okay, this is the point where the function goes to the lowest, but how low does it go? So we want to find the actual value of that point, like the actual, like maybe that's a 1. So we want to say, yeah, we have a minimum at 2, and its value is 1. So the function at that point goes as low as 1. Okay? Hopefully it might make more sense as we do some examples. So the test we did last class to find out increasing and decreasing is actually called the first derivative test. And so this is kind of what we did. This is kind of a summary of that. You identify the critical numbers, C, for the function by setting the derivative equal to 0 or finding where it's undefined. And I'll talk more about this later. For any x in the domain of the function. So kind of ignore that for now. And then we're going to find that f of c is a maximum if the derivative is positive, less than c, and negative, greater than c. So that just means it's a maximum if it's going to be going up and then coming down, right? So increasing and decreasing. And then the next bullet point just says it's a min if the derivative is going down when it's less than c and going up when it's greater than c. Okay, that makes sense? Okay, now, and here's where it gets a little bit tricky, because if a value of x that makes the derivative 0 or undefined, then if it's not part of the domain of the function to begin with, then it's not going to be a min or max. So we're going to talk more about that in examples. So actually, yeah, I'll hit that later. The main thing you want to remember here, like I mentioned, the biggest mistake people make is here. We use the derivative to find our x values, right, to find the critical numbers, but to answer the question about how high or low a function goes, that's a bad choice. That's not good either. To find out how high or low a function goes, you've got to plug it back into the actual original function. Okay? Sure. Okay, questions about that? Okay, so let's try one. All right, so we want to find the relative extrema for this function. So again, first part of this looks just like our homework. So what are we going to do? Take the derivative. Okay, so we take the derivative. Now, is there anywhere where this derivative is not defined? No, right? Because there's no x's, there's no denominator with any x's, right? So we don't have to worry about that. So, so we don't have to worry about getting critical numbers that way, but we do have to set it equal to 0, right, and get critical numbers. So how do we solve that? What's that? Take out a 6. Were you just jumping ahead? So Grace is just moving ahead of all of us. So we take out a 6, right? And we make it this, and then we're going to factor, and it can factor to so x plus 4x. I don't know. I mean, I don't have to do all these steps, but okay. So x plus 4x minus 3. So therefore, our critical numbers are, Grace, -4 and 30.
I thought it was.
No, because we had to get a positive one out of it. But this is negative.
The plus 6 should have been it.
Oh, shoot. Yep. Sorry about that. Let's actually go right down that way and make that positive. No, a negative. A negative. So then it's -4, +3, and then +4, -3. There we go. Okay. So now we know we've got those numbers on our number line. So -3 and 4. So those are all the numbers we have, right? The only critical numbers. So we know that if a min or max is happening, it's going to be at one of those. So now we just have to figure out whether they're increasing or decreasing, right? So we're going to choose a number here, and we can choose what? Like -4. So again, did you all use that shortcut method of finding the values? Can you get that, Kathleen? So by plugging it into this, the factor form, right? So we bring down our 6. -4 minus 4 gives us -8, right? I'm plugging it into here. -4 plus 3 gives us a -1, right? Because again, we don't care what the derivative is of -4. We just want to know its sign. So this is going to be positive. Everybody agree with that? So it's increasing. What can we choose between -3 and 4? 0. So we find the derivative at 0, and we keep our 6. 0 minus 4 is -4. 0 plus 3 is +3. So it's negative. So it's decreasing. So what's happening at -3? What do we know about -3 already? The max, right? And then we check out our last interval, and we can choose 5 maybe. So we found 5, and we get 6. 5 minus 4 is 1. 5 plus 3 is 8. So it's positive. So it's increasing. So what do we know about 4? The min. Okay. So we know we have a max at -3, a min at -4. Now, the formal way to answer this, again, we're not quite done at that point. What happens is we say that we have a relative, max at x equals -3, okay, because the x value tells you where it's happening. But we want to find out what is a relative max. If we're saying that the function gets to the highest point at -3, we need to say, what is that value? So we plug -3 into our original function. So we want to find f of -3. So we're going to do 2 times. So I would get out your calculators. And let's try it, because a lot of people make mistakes on this thing, on this. Okay, so on this, I know a lot of people make mistakes like plugging in values. So I highly recommend that you do it like this, like do the whole thing at one time. When you try to split it up into like little pieces, I just feel like it can cause more mistakes, right? So when we plug in -3 into the original equation, we get 150, right? So that what that means is there's a relative max at -3. Oh, shoot. At -3 of 150. Okay, so that's the correct way to say it, right? So that the max is happening at -3, but the max is 150. So we have a relative max at -3 of 150. And then at 4, we have a relative min, right? And it's happening at 4. And again, if we look at our equation, when we plug in a 4, we get the -193. Now, do you all know how to do that? Like how to, if you wrote this once, you can like go up. Well, the way I do it, you can, hang on. You can do a second enter, and it gives you what you just typed in. You all familiar with that? And then you can go in and just scroll through and change the values. Don't know how many don't know what I'm talking about? Okay, all right. So it's just a handy tool to make sure you get it all, you do it right without having to type it in twice. Okay, so so F4 is -193. So we have a relative min at x equals 4 of -193. Okay, does that make sense? Okay, so actually what we're going to do, so that's the steps you're going to go through. What we're going to do now is go through a couple different types of problems. So because it just gets a little more complicated, but you only had a certain amount, a very limited number of types you did for homework. So we want to try these other ones. Okay, so this next one. So we've got, again, just different type of equation. So first of all, though, is there any number that's not, that you're taking out the domain here? Like, do you have any x as a denominator here? No, right? So it's all good. So right now, any number could be a min or an x, okay? So keep that in mind. So actually, I'll go ahead and put the domain is all real numbers. Okay, so first step is take the derivative. So we bring down the 2/3. What is 6 times 2/3 going to give us? 4. Awesome. So 4x to the -1/3 minus 4. If we rewrite that, we get 4 over x to the 1/3 minus. So this is the whole reason why I've been so obsessive about rewriting it, right? Because now when we start to solve it, we really need to know that that really is in the denominator, right? Okay, so is everybody good with this being the derivative? So is there any value of x that would make this undefined? 0, right? Because even though we have a -4 here, this can't have 0 on the bottom, or it's going to blow up. It's undefined. I'm thinking of the computer programmer in me. If this was a 0, the program would bomb. So, yeah, so it's undefined. So right now we know since x can't equal 0, we have a 0 as a critical number. Okay. Okay, and then now we also have to set equal to 0. Mary Grace? Well, no, the reason is because 0 is okay in the original function, okay, right? Because everything was okay in the original function, but it's not okay in the derivative. So we add it to our number line. If 0 was not in the domain of the original function, and also not in the domain here, we would not add it, okay? Because there's no way, if 0 couldn't be in the original function, there's no way it can be a max or a min. Okay, so we don't go looking for it. Does that make sense? Because if this kind of had, like if this had an x in the bottom up here, where x could not equal 0, then we don't even put it here because it can't be a max or min if it doesn't exist. You don't have to worry about it if it exists, if it's out of the domain in the original and out of the domain of the derivative. Okay? And I'm going to revisit that. We'll talk about that more when we get into one that we can ignore. Okay? All right. so what else do we have to do to see what else is a critical number? So that equal to 0. So all right, so how do we solve that equation? Plus 4, so we get this. Awesome. So it's, right, so 4 equals 4x to the 1/3. On a roll. Molly, what next? How do we get that x by itself? 5/4. Everybody following this? Because now it's going to get a little bit tricky. So if x to the 1/3 equals 1, what does x equal? 1, right? How did you do that? It's kind of intuitive on a 1, right? I mean, 1, okay, but what are you actually doing here? Well, this is saying that the cube root of x equals 1, right? But what if, just to prepare us for the next example, what if it were this? There you go. So you cube this side and this side. Does that make sense? So then 1/3 times 1/3 to the third gives us 1, and it equals 8. Okay? And this comes up, this exact problem is going to come up sometime in the next couple weeks. So it's the same thing though. If I told you the square root of x equals 5, what does x equal? Nellie, what's x equal? Why? What do you do? You square both sides. Okay? So, and this is the same as x to the 1/2, right? So anytime you have x to some fractional exponent equal to a number, you have to like undo that root by taking it to that power. Does that make sense? Because your goal is to get it to x to the first. All right? Okay, so again, this doesn't have anything to do with this problem in particular, but it's how we get here. All right, so now we have to add a 1 to our number line. Okay? Actually, let me do that. Shoot. Okay. I'll just make note. Okay. So now our number line is 0 and 1. So we have to find out if it's increasing and decreasing, right, for every interval. So what do we want to choose for 0? -1. So we find the derivative at -1. So 4 over -1 to the 1/3 minus 4 equals 0. So cube root of -1, we don't really is what, actually? -1, right? Because -1 times -1 times -1 give you -1. So this becomes -4 minus 4 equals -8. So we get them decreasing in that interval. What about between 0 and 1? What do we have to choose? 0.5, right? Or 1/2? Okay. No, actually, okay. That would be one answer. But since we're going to have to take a cube root of a number, let's choose 1/8, right? Because then the cube root of 8 is 2, so the cube root of 1/8 is what times itself 3 times will give you 1/8? 1/2. See, Natalie, this was a great day to come in and tell me you didn't like fractions. Okay. All right, so we're going to choose 1/8. So if we do, what's that? Not many do, actually, but we're going to keep going and trying it. Okay, so we've got 4 divided by the cube root of 1/8 minus 4. So let's keep, and we already said the cube root of 1/8 is what? Well, the cube root of 8 is 2, so the cube root of 1/8 is 1/2. 4 divided by 1/2 is what? 8, right? Because you take the 4 times 2 over 1. Are you all with me here? Stop me if you have questions. Well, okay, how do you do 4 divided by 1/2? How do you multiply, how do you divide fractions? So we keep the 4 the way it is, right? We change it to multiplication, and we flip the 1/2. So we get 8. Okay? What's that? Is it, yeah, I think so. Oh, crap. See? We did pause it. I know. Okay. I know, I will. See, that's what you all, well, I don't know why it keeps disappearing. Normally it's up there. Oh, no, it is recording. Oh, sorry, Katie. It's like, crap, we stopped recording. Yeah, no, Katie's been listening to all this. Yeah. No, that's fine. Sorry. She might just listen to us for like comic relief later on. But yeah, so she's been listening to all this. And how long are we going on so far? 26 minutes. Okay. Okay, that's all right. She can turn us off whenever she wants to, right? Okay. So between 0 and 1, it's positive, right? And then greater than 1, we can choose 2. And if we plug in 2, what's that? Oh, there you go. Choose. See, somebody's listening. So yeah, instead of 2, we're going to choose 8 because we have to take a cube root, right? So cube root of 8 we know is 2. So we take 8, 4 over the cube root of 8 minus 4. So Natalie, 4 over what here? 2 minus 4, right? 4 over 2 is 2. Minus 4 is negative 2. Everybody agree with that? All right, so we got negative. So these problems go on forever. So 0, what's happening at 0? Min or max? Min. And what's happening at 1? A max. So now we plug it in the original equation. And actually, this finally gets a little bit easier here. So if we go up to our original equation, we have, did I say a min at 0? Is that right? Min at x equals 0. If we plug in 0 to our original equation, what do we get? What's that? 0, right? So 0 minus 0. Okay, by increasing and decreasing. So we knew, where's my number line? So if it's decreasing, the 4 gets to 0, and then increasing, so then it's going down, then up, so we know it's a min. And if it's increasing and then decreasing, so it's going up and then down, we know it's a max. Okay? So we know we have a min of at 0 of 0, and we have a max at x equals 1 of what? 2, right? Because 1 to the 2/3 is going to be 1 minus 4 times 1, so of 2. Okay, make sense? All right, I'm going to pause for just a second. Okay, so we're going to do this last one because it has a number outside the domain, right? Like this was the original function, and what number is not in the domain of this function? What number is going to make the, right, the denominator, right? So right away, the original function, the domain, x cannot equal negative 2. Okay? So if we find that as a critical number, we don't have to use, we're not going to use it because it can't be negative 2. Okay, so that's kind of helpful. Okay, so now we take the derivative, right? So derivative of the top, 2x minus 6, right, times the bottom, minus derivative of the bottom times the top, all over bottom squared. Now, how do we simplify that? Right, distribute or multiply 2x minus 6 times x plus 2, right? So we get 2x squared plus 4x minus 6x minus 12. And then I'm going to go ahead and distribute this negative. So we get minus x squared plus 6x minus 9. Everybody follow me? Okay. Then when I combine like terms, I get 2x squared minus x squared gives me 1x squared. 4x minus 6x, well, actually, negative 6x plus 6x cancel out, so we get plus 4x, and then minus 21 over x plus 2 squared. This problem actually turns out to be not too bad. Okay, everybody good with that? Okay, so now when we look to what we have to add on our, I keep wanting to call it a timeline, on our number line, so what would make the denominator 0? -2, but it also makes the original function 0, right? So it cannot be a min or a max, right? So we don't have to put that on our timeline, on our number line, okay? But what we do have to do is set this equal to 0. And if we solve that, we multiply top and bottom, right, by the denominator. It cancels out, and we get x squared plus 4x minus 21 equals 0. And how do we solve that? We can factor, right? So multiplies to negative 21, adds to 0, adds to 4, but plus 7 minus 3. So we get x equals negative 7 and 3. And then actually, I want you all now to go ahead and let's choose what? Negative 6, 0, and 4. Negative 8, that's a test. Good job. 0 and 4. Okay, so I'm going to turn, Katie doesn't need to listen to more right now. So I'm going to turn that off, and you all tell me whether it's positive, negative, or. Right. Okay, because of the original function. So in the one we're doing right now, x cubed equals negative 2 is the original function. So therefore, there's no way it can be a min or a max, all right? But in the problem before this one had the domain with all real numbers. Okay, so then when we found a number that was undefined for the derivative, it could be a critical number because it existed in the original. Okay? Well, first you plug in negative 8, 0, and 4 to find plus, minus, or plus. Okay? And then you're going to find out whether negative 7 is a min or a max and plug it into the original to find out the value. Okay? Okay, so hopefully you found it's positive, negative, then positive, right? So we have a max at -7 and a min at 3. And then has anyone plugged these in yet? Somebody plugging those in for me. I don't know. For 3 is 0. -7 is -20. For 3, so 3 would be 9. Well, yeah, 9 minus 18 plus 9. Yeah, so 0. Yeah, always be careful when you have a 0, just to make sure. Let me get Katie back on. Oh no, she's back on. Wasn't she? Yeah. Okay. Let's see. So 49 minus 42 is 7 plus 9 is 16 over, yeah, 16 ninths maybe? Or, oh, plus 42. Yeah, yeah, because it's negative. So yeah, I think right. Yeah, negative 20. Okay. Well, actually, I'll look at this while we go to lunch. So we have a max at -7 of -20 and a min at 3 of 0.